Hello and welcome back to module number 8. In today's module, I'm going to talk about going to do a review of the hypothesis testing, but in the end of the module, I'm going to do correlation and regression analysis, and I will again extend it to the next module to talk more about that. I will show you part of it in R, but again, the issue is for this presentation, in this form, I want you to have understanding of the idea behind those procedures. I would like to start though with basic terminology that I did not do last time. We are talking about two types of studies here. One is population, which is all possible values from data, and comparison to a sample, which is a proportion of the population. We are going to talk about that with regard to hypothesis in testing, and we will talk about that in the context of how do we estimate that, what we can learn about the hypothesis, and how can we make reference to the population based on what we found on the sample. So we are going to talk about two types of analysis. The analysis of the population, which is the parameter, and the statistics, which is the calculation of the sample, and we will see again the difference between them. In the hypothesis, I will lay out for you a very straightforward steps, which will be defined as what is the null and what is the alternative hypothesis, what is test statistic, and what is a p-value and its interpretation, and what is significant level. When we are talking about hypothesis testing, we are wondering, or we are trying to determine whether a statement about the value of the population should or should not be rejected. So the idea here is that we have two types. One is the null hypothesis, which is a tentative assumption about the population, and where the other one is the alternative hypothesis, which is the opposite to what the null hypothesis is. So basically, we have two statements, and one of them has to be true. And that's the thing about that. So we are trying to compute statement that indicate by age 0 and age 1, and try to see what is it makes out of it. How do we develop hypothesis testing? It's not always obvious to know how to formulate, and some books or some people like to start with alternative and then move to the null hypothesis. So you need to, what I would like to I would ask you and expect from you is to have some thinking about that before you jump in and start stating the null and alternative hypothesis. So you need to provide some understanding in the context and what you should do in that regard. So in some cases it's easier, easier to identify the alternative, which is what basically you were trying to make a point, and in some cases the null hypothesis, which is the opposite. So basically it's the measurement. So alternative hypothesis example is many application of hypothesis involved in attempt to gather evidence in support of the research hypothesis. So example, I did the study about the evidence about students' occupation, students' ability to learn. So my hypothesis, alternative, is trying to support my hypothesis, and the null hypothesis is trying to reject my hypothesis. So in many cases, it is best to start with what you support in your hypothesis, and the rejection will be the null hypothesis. Let's start with example. A new teaching method is developed and it is believed to be better than the carrot method. Okay, so the alternative hypothesis in this case will be the new teaching method is better. The null hypothesis will be that the new method is no better than the old methods. So again, see what is the difference between those two statements, and your objective and your goal is to prove that one of them, your alternative hypothesis, is true and the null hypothesis is wrong. So a new Salesforce bonus plan is devoted to attempt to increase sales, right? So alternative will say, yeah, let's go with a new plan to increase sales. But probably people from older times will say, no, we want the new plan does not increase sales, it's only increase paperwork. So again, two alternative hypotheses and what it is. Another example, a new drug is developed for lowering blood pressure more than the existing drug. So if I will ask you is, what is the alternative hypothesis? It will say, yes, we support this is the whole premises of our research, which is a new drug lower blood pressure more than the existing. The null hypothesis, on the other hand, is a new drug does not lower blood pressure more than the existing. So your objective is to reject the null hypothesis. So the null hypothesis as an assumption can be challenged. Example, and you need to start digging into the data in order for you to verify it. So it will be easier for you to state the null hypothesis. So the label on a soft drink bottle states that it contains 67.6 liquid ounces. Okay, this is the entire premises. So how can I convert it into a hypothesis, and specifically to null hypothesis? I will have M is equal or bigger or smaller than 67.6 ounces. And the alternative is that the label is incorrect, and in this case the M is smaller than 67.6 ounces. So again, look at how I played with the null hypothesis and alternative hypothesis to make a statement. Now we need to start talking again about the population mean. The mean, again, if we will summarize it, is the sum of value divided by the number of value, if possible, are equal. Okay, so the population and the sample mean, it is we collect the data, we sum the value in the population and the sample, we divide the sum of the numbers of the elements in the population and the sample, and compare what is the population mean versus the sample mean. Okay, so we have the terminology. Now we can apply that into our hypothesis. So in general, the hypothesis test about the value of the population mean must take in the following three forms. So it has to have three forms. The first one is one tail, which is lower tail. The second one is the upper tail, and the third one is two tail. And so again, it's a little play with regard to the mu, with regard to the population mean and the sample mean in that case, and how we apply that into our hypothesis. The one tail, I will show you how to apply that. I will show you how to apply that into the R and why is the R so great about that. But I'll also demonstrate the one tail and the two tail with the art example from the R, because again, my objective is that you will have a broader vision of what is the hypothesis all about. So again, let's take an example with the mean. Emergency service is meeting a respond goal. Non-follow-up action is necessary. So this is the the null hypothesis. The alternative hypothesis, the emergency service is not meeting the response goal, and appropriate follow-up action is required. The mean in this case is the response time for the population of the medical emergency request. But as you probably think about that in some common logic way, because the hypothesis tests are based on a sample, we are talking about in terms of population, we must allow ourselves to have error. And there's two types of error. Error number one is the rejection the null hypothesis when it's true. So the probability of making type 1 error is when the null is true, and as a result it's called level of significance. And in this case, the application of the hypothesis testing that only control the type 1 error are often called significant test, and we will see how it play out. Type number 2 is accepting the null hypothesis when it's actually false, and that can happen too. So it's difficult to control the probability of making a type 2 error, and usually we are talking about when statisticians avoid the risk of making a type 2 error by using do not reject the null hypothesis or do not accept the null hypothesis. But if we will sum up with regard to what we come up with, the conclusion from our hypothesis with regard to the population condition, this is where things has to do. If we accept the correct decision about the null hypothesis, we might have reject the null hypothesis. It is type 1 error. And if in comparison to the sample versus the population, and when we are talking about the population false, we are talking about type 2 error. And if we reject the null hypothesis, maybe we might be right. So we talked one tail. And the p-value is when we are trying to use to calculate the probability to measure the support or lack of support to provide by the sample for the null hypothesis. Again, we are taking a sample about the population and we are trying to avoid one-tail hypothesis testing error. So in this case, if the p-value is less or than equal to the level of significance, the level of test statistic is in the rejection region. And so we reject the null hypothesis if the p-value is smaller than bigger than the mean. Okay, so what is the value that we need to consider ourselves in that premises? Less than 0.01 overwhelm evidence to conclude that the alternative hypothesis is true. In between 0.01 and 0.05, we have strong evidence to conclude that the alternative is true. And between 0.05 and 0.1, we have evidence to conclude is true, but it is weaker evidence when we have a stronger evidence. And greater than, it is insufficient to evidence to conclude that the alternative is true. So lower level, what does it entail for us to calculate the population of the mean when it's known? So in visualization, because this is my passion, this is what I dream at night, I want to show you what it is entail. So in this case, the p-value is smaller, so we are rejecting the null hypothesis, and it goes to the left side when the z, with regard to the z-value. In this case, the z-value, or if we converted the z-value to p, it will be 0.072. And on the other hand, when we have the p-value also smaller than the mean, so we also reject the null hypothesis to the right, and so the p-value in this case is 0.011. So one trial approach is that we are taking a statistical z-test in order for us to test the standard normal probability distribution, and we use the standard normal probability distribution table to find the z-value. And you can find the z-table all around the web. If you search for z-table, you will find it. Most statistical textbooks do not carry anymore the z-value. It is sometimes hard to find. It is sometimes hard to find the accurate value of it. So the value of the test statistics that establish the boundary of rejection called critical value for the test. So in this case, we are lower tail and upper tail, and this is where we come into play. We also do not have reject the null hypothesis, and again, this is when the upper tail and the step to test it, and this is where I think this is PowerPoint presentation that I created is really powerful. Why? I'm giving you the steps in hypothesis testing. The first step, you're going to develop null and alternative hypothesis. 2, you're going to state out the level of significance. In your homework assignment, you will given the level of significance. Usually it's 0.05, and you need to specify or to understand where it comes from. Then you collect the data from the sample, you compute the value of the test statistics, and then you will come into play with regard to the p-value approach. The p-value approach is the step number 4, where the use of the value to compute the p-value. So in this case, by finding the p-value, we can say, is it smaller or bigger? And if it's smaller than the mean, we are rejecting the null. So the critical value approach uses the level of significance to determine the critical value and the rejection rule, and use the value in step number 5, use the value of a test statistic and the rejection to determine whether to reject the null hypothesis. Example, again, the response time for a random sample of 40 medical emergency were tabulate. The sample mean is 13.25. The population standard deviation is 3.2 minutes. And so we need to determine, and in this example, we are giving you the level of significance. It is 0.05 to determine whether the service goal of 12 minutes or less can be achieved. So in this case, we are determining, we have the value, we know the formula, the z equal the formula of that, and we determine that the value is 2.46. But this is not the end, because we now have the value of z. We need to calculate the value of p-value. So the accommodate probability is 0.99 if we convert it into the z-value, and in this case, the 1 minus the value of the z-score will give us the value of probability. In this case is 0.0068. So in this case, we can determine whether to reject the null hypothesis. So in this case, we are reject the null hypothesis, and we are that there is no meeting to respond to the goal of 12 minutes or less. The strength of this approach is that, again, the ability to my visualization, I hope, make more sense to you now, make more determination. The critical approach, again, is to determine where is it lies out and how to apply that into the R. And I'm going to show you one aspect of the R with regard to the population. I'm not going to give you everything into it, because in this case, just the idea. So the sample mean in this case is X bar, and it's 13.25. The hypothesis level value, sorry, it is, I'm calling it mu0, and I'm giving it a value. The sigma is the population standard deviation. The n is the number of sample. So the z is, I'm writing this formula, it is not embedded into the R, and so it's z bar minus the hypothesis level divided by sigma divided by square root of n. So in this case, it will give me the result of the z, and without me going back and forth with the table, the z table. So when we compute the critical value of 0.05 level, we are in R, I will call it an alpha. So in this case, it's 0.05. So z alpha will be a normal distribution, alpha minus 1 minus alpha. So minus alpha in this case will be minus 1.6449. And so this is where I'm doing it in R, and I will give you more directions and more illustration to it in the assignment that you will have. But this is the premises that we are working with regard to the R. Okay, so now I'm back to my theoretical subject of this module, the two-tail. I'm not going to go over the T for the R. I'm going to go how I calculate that, so you will have that. So in two-tail hypothesis, we compute the p-value using 3 steps. 1, to compute the value of the test statistic of z. And step 2 is, if z is the upper tail, we compute the probability that z is greater than or equal to the value of t test statistic. And if z is lower tail, we compute the probability that z is less than the equal value of the test statistics. And we double the tail area, obtaining in step 2 to obtain the p-value. So the rejection is if the p-value is smaller than the mean. So the critical values that will occur both the lower and upper tail of the standard normal curve. So in this case, the use of standard normal probability distribution table to find the z value will give us some directions how to do that. So the rejection rule in this case will be in the following formula: z smaller than minus z multiplied by mu divided by 2, or again same formula in a different way. Another way to test about the population of the mean when it's unknown, when the mean is unknown, is t statistics. So the idea here is that we are testing the t distribution with n-1 degree of freedom. So how do we do that? The rejection of the p-value approach. We reject the null hypothesis if the p-value is smaller than the mean. So in this case, the rejection rule critical approach will be outlined in the following forms. This is the null hypothesis. We reject if the t smaller than or bigger than, and this is how we reject to it in those 3 conditions. And you will have the PowerPoint presentation in order for you to see that, in order for you to go over that, and also the textbook, also both textbooks for the course, and I'll give you the outline and give you the specific pages where you're going to search for it. But we are talking about 2 things that I need to clarify here: p-value and the t distribution. And again, in probability and statistics, T-distribution is any member of the family of the continuous probability distribution that raise when estimate the mean of normal distributed population, and is where the sample size is smaller and the population deviation is unknown. This is where we use the T-distribution to do that. The format of the T-distribution table provides us statistical textbook do not provide, again, as the p-value or the z-value does not give us enough detail to determine the exact p-value for the hypothesis. So again, however, we can use it as the T-distribution table to identify the range of the p-value, and again, the power of R is that it provides us the calculation, so you don't need to go to the table back and forth as you did with the z-score. Yay! So this is one of the shortcuts that the R provides us. The only observation is that you need to define how to implement your hypothesis and your p-values into the R in order for you to do that. I will show that in the assignment, don't worry. So again, the p-value and the critical approach determine the hypothesis, specify the level of significance, compute the value of the test statistics, and compute the p-value and determine where it's at, determine to reject or accept the null hypothesis and how it comes about. When we have a 0.05, it is 95% confidence that the mean speed in this case, I gave you an example in my own case, is faster. And again, this is not the issue. The issue is the steps that I'm taking to show you how to apply that. So the issue is that I want you to remember, what does it entail? What is the formula that we embedded into it, and how do we determine that 95% confidence of the mean will give us a good indication to accept or reject the null hypothesis? In this case, we are rejecting it. So again, the visual power of it and how to apply that. And again, summary of the whole thing, and in general, the hypothesis test is about the value of the population proportion of the P that must make the following forms, and I outlined for you the one trail, two trail, and the one trail, the lower trail, upper trail, and two trail. And I want you to keep it in mind when you are thinking to phrase your hypothesis and when you're going to use it into that. Another test about the population is the t-test. And again, I give just an example just to fill out, to give you the assumption and how to apply that. So in many decision making, the situation of the decision making may want, in some cases, may be forces to take action that both conclusions do not reject the null hypothesis and the conclusion reject the null hypothesis. So in this case is a type 2 error that we are trying to avoid, and it is recommended to follow up the 2-type error just to make sure that we are on the right track with regard to our conclusion. So we talked about significant test, we talked about test about the sample and the population. We talk about technique to introduce by considering one sample test, the z-test. We talked about proceeding is broken into 4 attempts, and we talked about each element of the procedure must be understood when you are writing your report. Okay, so this is my summary of the statistic hypothesis testing. I will give you step by step and instructions how to apply it to the R, and I hope that will make sense. Your job, if you do not understand anything, is to come back to me and just ask questions. My job is to answer. Okay, so the next chapter that I want to start covering, and I want you to have some sense to it, and also imply in some form, in some way, to hypothesis testing is correlation. What is correlation? We're going to talk about correlation coefficient. We're going to talk about type of correlation. We are going to talk about measure of correlation and introduction to regression and the last square of regression. So, what is correlation analysis? The correlation is a single number that describes the degree of relationship between two variables. Let's work with example show as a statistical to compute. When we are talking about correlation, we are talking about in terms of +1 or -1, where we also have the zero that will show that the relation between the two variables are very weak when it's very close to zero. So we have positive as a result that when we are showing strong correlation between two the variables is +1, and a negative correlation is -2. In that type of analysis, we have three types of correlation: Pearson, Kendall, and Superman correlation. I call it Superman. I like that idea. So the idea of correlation versus regression. In correlation, we measure the strength of the association between the two variables. In regression, in comparison to correlation, we are making prediction about the value of the independent and the dependent variables and how they affect each other. So the idea of regression analysis is to explain the impact of change in the independent variables on the dependent variables. So it's not one causes the other. It's like the association or there is no association in those two types of analysis, and I want you to remember that. Dependent variables is that the variable we wish to predict or explain. The independent is the variable used to predict or explain the dependent variables. And that's how I see regression, and I want you to make the clear correlation between correlation and regressions and how it's done. When we are talking to another terms in correlation, we are talking about correlation coefficient, and it is the measurement of strength of the linear association between the two variables, and it is the Pearson production moment correlation as one of the best way to do that. We usually apply diagrams in order for us to show that, where we show the independent variables versus the dependent variables, and usually the data come across as a line as sees in this illustration. So in this case, insurance company concerned about the health of adults, since the company is prepared to give a reduced rate, and based on it, he wants to see the number of the adults, 12 adults, the weight and the height, and see what is the correlation between them in order for it to idea. So the Pearson product correlation coefficient will measure with two terms. One is the R, which is the value of the correlation coefficient calculated from the sample of the data, and the P, which is the correlation coefficient calculated from the entire population as devoted by the Greek letter P. So in this case, we have two values, the R, and we have the S, with three different types of formulas to calculate or to find that. So in this case, you have to know that in order for you to calculate. So the S by the power of X is the standard deviation of the X. The S by the power of Y is the standard deviation of Y. The N is the number of pairs of observation, and the alternative formula for calculation is the following. So we have the value of R must always lie between -1 and 1 plus 1, and we also need to consider the idea of where the 0 is and how we apply into that result. So negative and positive, and if the two variables are negative, that means that the larger value of x is associated with the smaller value of y, and the smaller value of x is also associated with the are associated with a large value of y. So in this case, this is what is the output of it. Perfect correlation, it's a straight line, higher positive, there is some same round of dots, and lower positive correlation, something like that. Negative, same thing. And again, the idea. So how do we do that? In this case, we denoted the x and y, and we sum up the values, what I collected from the health insurance company, and we came up with that. Another way to us to do that is Superman rank correlation coefficient, which is the degree of association between the two variables, is the rank correlation or coefficient. And the idea here is, again, different observation, different calculation to it. In this case, we have the D, which is the difference between the corresponding pair of ranking, and the N is the pair of observation. In this type of calculation of correlation coefficient, we are using plus and minus the same way as we did the previous or in correlation analysis. And when we do super intensive, again the same thing, we are testing the value of R, and in this case we are applying that in order for us to do that. So the interpretation of the correlation coefficient, we are testing the value of S squared, we are testing the value, we are doing the two tests in order for us to see the assumption in, to examine the relationship if it does exist between the two sets of ranking data, and by doing that we are able to apply and to do that. Okay, in R, and this is where life begins, from my understanding, life begins to become very clear. The idea of correlation test is core.test, and you are able to define the x and y, and the methods, you can have the three methods that I discussed previously. So you can define what it is. You can also have, if we are talking about hypothesis, you can state it in your hypothesis in the correlation analysis in R about two sides. You remember two sides, or greater or positive? You can apply that in order for you to do that. So in this case, confidence level is the confidence level returned from the hypothesis testing. For example, I'm taking a sample of 1 to 20. I'm taking plus random number of 10 with the standard deviation of 2. And I'm taking the y, which is x plus random numbers, 10, and the standard deviation of 2. And I'm taking another form. I'm taking the z, which is the sample of 1 to 20, and I'm dividing it to 2 with a standard deviation. When I'm doing random numbers of 20, I'm doing it with standard deviation of 5. Now a new terms that I'm using in this case to do calculation. It is the data frame. Data frame holds all the data in one container in order for me to observe the x, the y, and the z in one container. And so in this case, I can do person, I can do Superman, or I can do any type of analysis in order for me to calculate that. And this is again the power of R with regard to how I apply that. So in this case, person correlation, this is what I found. In Superman, this is what I found. And where is the biggest asset of the R? In the last statement, a simple estimate will give you where it stands and how it apply 0.87 and 0.88 and give you the entire layout where you need to do your calculation. So this is where everything come into play, and again, how to apply that and how to apply that. Okay, so what have I done today? I talked about hypothesis, I gave you the layout of hypothesis, but I also started to introduce to you the correlation analysis and the relationship. We'll learn how to draw, we should have learned, I will show you that in the example in the canvas. I will show you the diagram that you can create, the product movement correlation coefficient and the ranking correlation, and we will show how to test the correlation for significant otherwise. That's it for all. I hope you enjoyed. I know that it's a long video that covers a lot of material. I will give you specific pages that I want you to read, and I insist that you will read in order for you to do that. Again, hypothesis testing and correlation is the foundation of statistical analysis. This is really important. So again, please let me know if my notes make sense. If not, I will correct them. Otherwise, please read the notes. Please review the outline that I did in Canvas. And until next time, have fun.